Hello class, this is the last example for March 25th, and this will be exponential decay. We are still using the same model that we used from the questions before. The only difference is that now we have a negative exponent or a negative rate. When we have a negative sign in an exponential graph, it flips the graph the other way. So one of the slides that you have should show you the two different graphs of exponential growth and exponential decay, and you'll see how the decay with the negative exponent is decreasing. So in this example, we have a particular substance that has a half-life of 140 days, and we are starting with 300 milligrams. So we know that the initial amount is 300 milligrams. And we want to find what the rate of decay is to start. So let's start by finding K. The half-life is 140 days, so that means we would have 150 milligrams of the substance after 140 days. I'm putting 140 for T for the time. The initial amount was 300, and then half of that quantity is 150. I'll divide both sides by 300. I want to get the exponent by itself. So that I can take the natural log of both sides. So natural log of 1/2 and e to the negative k times 140. All right. So I have natural log of 1/2 equals negative k times 140, and then dividing both sides by 140. Actually, I'm going to divide both sides by negative 140 because I want to just figure out what k is. And actually, I'm going to put the negative sign up here so that I can use that rule of exponents and bring the -1 up into the front, because that'll allow me to take the reciprocal of the 1/2 and have natural log of 2 over 140 equals k. That's just a little trick that we use sometimes to get rid of fractions. Plugging that into the calculator, we get that k is approximately 0.00495. So now we have a new equation, which is, this is our model that we'll use. 300 is the starting amount. E to the negative 0.00495t. Remember that whenever we're talking about decay, then we have the exponent as a negative number. So this is the model that we're going to use. For the second part, we want to know how much of the substance is remaining after 1 year. So that would be 365 days. So we'll find P of 365. This is part B. 300 e to the negative 0.00495 times 365. And this is just plugging into the calculator, and you'll get 49.256. So this means that about 49 milligrams of the substance remains after 1 year. All right. For the third part, we're trying to figure out scroll back up here, how long it will take for the mass, for the sample to decay to 200 milligrams. So we're going to put 200 here. And we're going to solve for t in this case. So I will divide both sides by 300. And I have 2/3, oops, I want that to be red. 2/3 equals e to the negative 0.00495 t. And then take the natural log of both sides again. And so then we have natural log of 2/3 equals negative 0.00495 t. And we can divide both sides by that number. And plugging that into the calculator, we get that t is approximately 81.9. So the time required for the sample to decay to 200 milligrams is about 82 days. All right, if you have questions, send me an email and have a great day.